This is a home-built magnetometer to indicate the possibility of seeing the northern lights. When the sun erupts, solar wind, with charged particles, is thrown out from the sun's surface. Our magnetosphere is affected by these particles. The northern lights occur when particles that hit the Earth's atmosphere collide with the atoms and molecules that are there. The magnetometer shows changes in the Earth's magnetic field. A laser pointer produces a beam of light that is reflected via the mirror onto a white piece of paper. If you see a sudden, large change in the position of the laser dot, a massive change in the Earth's magnetic field has occurred. The magnet is made of two neodymium magnets at each end of a piece of metal. The piece of metal is a piece of a transformer core. To dampen self-oscillation, a copper tube is used. Inside the copper tube hangs the magnet. If the magnet moves, currents arise in the copper tube, generating magnetic fields that try to counteract the movement. The effect is called eddy currents, and it will provide natural braking for the magnet, preventing it from endlessly oscillating. The magnetometer is very sensitive. A truck with an excavator that was suddenly on our street 50 meters from the magnetometer gave a reading of 15 centimeters.